In this lesson, we'll continue exploring positional parameters, and you'll also learn how to create a while loop. Of course, as always, I'm going to start a terminal on my system and move into the folder for the class, and then move into the folder for the project that I'm working on, and then start the virtual machine, and when it comes up, we'll connect to it. Now that we're connected to our virtual machine, we'll move into the shared folder of /vagrant. And this script I'm going to name luser demo07.sh. Of course, we're going to start out our script with a shebang and give it a path to the bash interpreter. I'm also going to provide a little header here, demonstrate the use of the shift command, and while loops. In a previous lesson, you learned that the first positional parameter of $0 contains the name of the script itself, while $1 stores the value of the first argument passed to the script on the command line, $2 stores the second argument, and so on. We never actually used $1, $2 directly in that lesson, so let's do that now so you get a chance to see how that works and how they behave in different situations. So let's just display the first three parameters. We'll use an echo statement here. And I'm just going to copy and paste here. I'm going to add an echo statement here, which is just going to print a blank line. Now I'm going to save the changes to this script and then exit. Since this is the first time I'm executing this script, I need to make sure that it has the proper permissions. Now I'm just going to execute the script without any arguments. So there are no arguments, and that means there are no values to store inside the script as positional parameters. So of course, parameter 1, 2, and 3 are blank. Let's pass in one parameter and see what happens. We'll just call it with an argument of apple. So now $1 is assigned the value of apple, and that gets printed. So let's do this again with bread, gets assigned to $2, and let's say candy. So now $1 is apple, $2 is bread, $3 is candy, and we can directly access those and use those in the script by using $1 and so on. If we were to add more command line arguments, for example, another word here, let's say dumplings, then that is stored in $4, but we didn't account for a user entering $4, so that presents a challenge. And so that's why we're going to use things like for loops and while loops to handle command line arguments in many cases. Next in our script, we want to loop through all the positional parameters. In the previous lesson, we used a for loop to do that, but this time, let's use a while loop. So let's look at the while command. What type is it? Well, it's a shell keyword or a shell built-in. So that means we can use help against that command, help while, and hit enter to get some information about it. Now it says while commands, do commands, done. This executes commands as long as the final command in the while commands has an exit status of 0. You can think of this as being while true, do. While the condition that is being tested for is true, then the commands will execute. This means that during the while loop, you'll want to change the thing being tested for in some way so that the condition eventually evaluates to false, or you'll end up in an infinite loop. Let's create a while loop here at the command line. Let's use a variable called x. We'll assign that the value of 1. We'll use while. We're going to use our double brackets just like we did in the for loop. Now we're going to use a conditional expression. We're going to test if $x is equal to 1. If that is true, then what we're going to do is echo, this is the value of x, and then simply echo the value of x. Now we're just going to manipulate the variable x in some way. We'll just change it to 7 here and then type done. And so what happens is while, and that conditional expression, x equals 1, if that's true, and it is, then it executes the code block between do and done. So it echoes what you see on your screen, and then x is changed to 7. Now the while loop executes again. So it says, now is x equal to 1? Well, it is now false because x is 7, so it doesn't execute the commands below, and the while loop exits. This loop isn't really practical, but it demonstrates changing a variable that is being tested against in the conditional expression of the while loop. By the way, if the conditional expression never evaluates to true, then the commands in the while loop will never get executed. For example, right now the value of x is 7, so we can do echo $x. Sure enough, it's 7. And if we execute the while loop again, I'll just back up here a couple of commands and hit enter. Nothing happens because x-eq1 evaluates to false. When you're learning about the while loop and doing some experiments on your own, you're going to end up creating an infinite loop at some point. It's just going to happen. So let's do it on purpose and show how easy it is to break out of it. Before we do that, I want to introduce you to the true command. Its only job is to return an exit status of 0. So what type of command is true? It is a built-in as well as a program. Of course, we can get help on a built-in by using help, true. And it says it just returns a successful result. The exit status is that it always succeeds. Now, I happen to like the description of the executable better, so let's look at the man page for user bin true. So we'll just do man true, and it says do nothing successfully. I just love that definition. So in any case, no matter what happens with true, it just returns an exit status of 0. So we can test this. We'll just type the true command, and then we can look at echo $? Sure enough, it returns 0. If we do true blah, it doesn't really matter because again, it just always returns 0. Before we create our infinite loop here, let's look at just one more command called sleep. Sleep happens to be an executable program on the system. It's not a shell built-in. So we'll use the man page to learn more about sleep. So sleep simply delays execution for a specified amount of time. You can use sleep followed by a number and a suffix, and that suffix can be S for seconds, M for minutes, H for hours, or D for days. So sleep does what it sounds like. It just sleeps. It doesn't do anything for a specific amount of time. So I'll hit Q to get out of the man page here, and then just do sleep for 1 second. Nothing happens, and you return to the command line. Of course, that is the same as sleep 1S. And you can even do half a second or portions of a second. So let's do this, sleep for just a half a second and hit enter. Now let's build our infinite loop. So we can do while, and we'll test for true. True always returns 0, an exit status of 0, so it's always true. So this is going to never change. This while loop is going to run forever. So we'll just do while true, do. Then what we're going to do is just simply echo a random number. And now we're going to sleep for 1 second, and then we'll close out our while loop here with the syntax of done. Now when we hit enter, echo gets executed. It executes and displays a random number. Sleep rests for a second, if you will, and then the loop repeats because while true always evaluates to true. So this will just go on forever. Now to break out of this loop, all you have to do is hold down the control key and type C. So control C sends an interrupt signal to the command, which makes it stop. Now this isn't something unique to the while command. You can use this to stop any command running in the foreground. For example, if you execute sleep and want to interrupt it and return to the command line sooner, you can use control C there as well. So let's say we give sleep the instruction to sleep for 10 minutes, and then we decide we don't want to wait that long, so we'll just go ahead and type control C, and it breaks out of the command. Here on the screen, you can see the *C that shows that indeed these commands were interrupted with control C. There's one more small piece of the puzzle left to cover before we use a while loop in our script to loop over all the positional parameters. This last piece of the puzzle is the shift built-in. So we'll do type-A shift. It's a shell built-in. Let's get some help on this here. It says it renames the positional parameters of n+1, n+2 to $1, $2, and so on. Now what the shift command really does is that it removes positional parameters from the list starting with $1. It just chops off $1. So when you execute the shift command, the value stored in $1 is removed. It's just gone. What also happens is that the value stored in $2 shifts down to $1. $3 replaces the value in $2. 4 replaces the value in 3, and so on and so forth. Also, the special parameter of $$ is reduced by 1. Now, as you remember, $$ contains the number of arguments that were supplied on the command line. By default, shift shifts everything one place. Executing shift by itself is the same thing as executing shift space 1. If you want to shift everything by 2 places, use shift 2. In that case, $$ will be decreased by 2. If you want to shift everything by 3 positions, use shift 3 and so on. Now, if this sounds confusing, don't worry. It's actually harder to explain than it is to demonstrate. So when you see it being used in a script, it will make total sense. So let's do that right now. Let's use shift in our script. So we'll loop through all the positional parameters. We'll use a while loop, while, double brackets here. Again, make sure there are spaces in between while and the double brackets and a space after the double brackets. We're going to test for $$ here, the number of parameters. And we'll say if it's greater than 0, that means if there are any arguments on the command line, then this will evaluate to true. And at that point, what we want to do is echo the number of parameters is $. And then we'll echo the first parameter here. And we're just going to repeat this a couple more times here. So we'll echo $2 and $3. Then we'll echo a blank line. And then what we're going to do is use the shift built-in command. So just like we said, shift is actually going to modify $, because when it's executed, it removes one parameter from the beginning. $1 is gone. It shifts everything down. So that means at that point, the number of positional parameters has changed and $, is changed to reflect that. So we are modifying the condition that we are testing for through this loop. So we shouldn't end up in an infinite loop here. Of course, I'm going to end this with done. Save my changes, and then execute this script. So if we execute the script without any arguments, then there are no positional parameters to loop through. So that's why we only get the top portion of the script displaying some output, but we don't get any of the commands in the while loop being executed. Now let's supply just one argument here. That caused the while loop to execute one time. So $1 is assigned to Apple, then shift occurs, and so that removes $1 and shifts everything down. Well, there's nothing left to shift down, so $$ evaluates to 0. So 0 greater than 0 is false, so the while loop stops executing because it's false. So let's go ahead and add another argument on the command line and see what happens. So we'll add bread. So the first time the loop gets executed, $1 contains Apple, $2 contains bread. The shift command is executed, Apple goes away, the original $1 goes away, gets lopped off the beginning of the list there. Bread, which is stored in $2, then becomes $1, and there are no positional parameters 2 and 3. So let's keep doing this, and you can clearly see what's going to happen. We'll do candy. At the outset of the script, $1 is Apple, $2 is bread, $3 is candy. The first time the while loop is executed and shift gets executed, the number of parameters gets decreased by 1. So then there are only 2 parameters, bread and candy, bread being $1, candy being 2. While loop gets executed again, bread gets chopped off the beginning there, and you're only left with candy, which then becomes $1. The shift command is executed again, candy goes away, and there are no more positional parameters. So 0 greater than 0 is false, and the while loop exits. So let's do this again with one more argument. So as you can clearly see, every time we go through the while loop and the shift command is executed, everything shifts down by 1. So the while loop executes 4 times and then exits. It might not be obvious when you would want to use the shift command beyond our while loop that we've demonstrated here, so here are a couple of thoughts to keep in mind. One time shift comes in handy is when you want to have a user supply information as arguments to your script, and there is one argument or piece of data that can contain multiple words. For instance, data you would want to use in the comment field when creating a user. In this case, you would tell the user to supply a username, which would be $1, then you would shift, and then what is left over becomes the comments field, $1, 2, and 3, and so on. Now that's one example. Also think about processing command line arguments. For example, something like this, -a verbose. So just keep these ideas in mind, and we'll be coming back to them in future lessons and exercises. To quickly recap, in this lesson, you used positional parameters starting with $1 explicitly. You reviewed the special variable of $pound. You were also introduced to the true, sleep, and shift commands. Finally, you put all this new information together in order to create a while loop.